This is abel'stest or abel'stheorem of convergence of improper integration of type 2. What is type 2 abel'stest? In this case, the range of this integration is not infinity. Range is finite, but at the lowest range there be an infinite discontinuity, right? And we see the statement of this test. If fx be bounded and monotonic in AB and gx be bounded and integrable in a plus epsilon to b, because gx has infinite discontinuity at x equal to a. So at x equal to a, gx is not give for the finite value. So we take here the interval a plus epsilon to b, where epsilon is such that 0 less than epsilon less than b minus a. Having infinite discontinuity at x equal to a, also integration a to b gx dx convergent, then abel'stest say that integration a to b fx gx dx is also convergent. This is the second type abel'stest. We use here two important theorem of integral calculus. First one is second mean value theorem of integral calculus, and second one is Cauchy's criterion of convergence. And this Cauchy's criterion is necessary and sufficient condition of convergence also. We already proved this Cauchy's criterion of two types. Now we first use the second mean value theorem, because here fx is bounded and monotonic, also here fx is monotonic. So the first condition matched, and it is also given that gx is bounded and integrable. Also here gx is bounded and integrable. So we first start with using the second mean value theorem. So we write using second mean value theorem of integral calculus of Oysters form as integration a to b fx gx dx. Sorry, this is not a to b. We take here a plus epsilon 1 to a plus epsilon 2. Okay, and this is given by f of a plus epsilon 1 into integration a plus epsilon 1 to a plus epsilon dash. Sorry, this is epsilon dash gx dx plus integration. Sorry, this is f of a plus epsilon 2 into integration a plus epsilon dash to a plus epsilon 2 gx dx, where 0 less than epsilon 1 less than or equal to epsilon dash less equal to epsilon 2, and this is less than b minus a. Clear? And we name this relation as 1. Now it is given that fx is bounded, right? So we can write mod f of a plus epsilon 1, this is less than capital M, and mod of f of a plus epsilon 2, this is less than also capital M. And we write here there exists capital M greater than 0 such that. Okay, and this is 0 less than epsilon 1 less than epsilon 2 less than b minus a. This is the condition of boundedness of fx. Now here we use the definition of convergence of this improper integration. What is the definition of convergence of this improper integration? We use the definition of Cauchy's criterion. Since this is convergent, a to b fx dx be convergent, so this condition must be satisfied, because this is the necessary and sufficient condition of convergence, right? So we use this condition for the convergence of this integration. we write here, since integration a to b fx dx, sorry, this is not fx, this is gx dx is convergent. So there exists epsilon greater than 0. So for any epsilon greater than 0, there exists delta greater than 0 such that delta, this is equal to delta of epsilon, because delta is depend on epsilon. And now such that integration a plus epsilon 1 to a plus epsilon dash gx dx, this is less than epsilon by 2m, and mod of integration a plus epsilon dash to a plus epsilon 2 gx dx, this is also less than epsilon by 2m. Since 0 less than epsilon 1 less than epsilon dash less than epsilon 2 less than delta. Okay, now we name these two relation as 2, this two relation as 3, and this relation is 1. It is given. Now we taking mod on both side of 1 and putting the value of 2 and 3. We get mod of integration a plus epsilon 1 to a plus epsilon 2 fx gx dx less equal to mod of f of a plus epsilon 1 into integration a plus epsilon 1 to a plus epsilon dash gx dx plus mod of f of plus epsilon 2 into integration mod of a plus epsilon dash to a plus epsilon 2 gx dx. Putting the value, we get this is m, this is epsilon by 2m, and also this is m, and this is epsilon by 2m. So this is less than epsilon. If we write the final result here, we get mod of integration a plus epsilon 1 to a plus epsilon 2 fx gx dx less than epsilon. Okay, and this is nothing but the condition of Cauchy's criterion. We already write here, and since this is necessary and sufficient condition, and since this condition is satisfied by the integrand fx into gx, so we say that integration a to b fx into gx dx must be convergent by Cauchy's criterion of convergence. Okay, this is the proof of the second type Abel test.